Okay, so we're back for the next topic that follows up geologic history. And after you've been able to practice some of your geologic history questions, you've checked your answers, hopefully you have a better understanding of how to use page 8 and 9. So we're going to continue to implore the use of page 8 and 9 in order for us to be able to correlate rocks. Correlations in many ways are usually discussed as something mathematical, but occasionally we will use the word correlation to find that there are similarities between two things. In our case, we're going to be developing correlations using fossils between two geologic time periods and layers within the rock record. So let's take a look at some of this here. If you haven't had a chance, pause the video now, start reading through the introduction notes, maybe take some annotations, especially for vocabulary. I've already kind of given you an indication of what you really should be focusing on this page, and then let's take it from there. So if you need to pause, feel free to do so. Okay, so what I'd like to point out first and foremost, beyond the fact that we're just going to be correlating, is that we're going to be using very special fossils. I introduced you into the last lesson. At the bottom of page 8 and 9, they were called index fossils. I didn't define what those were yet because we didn't need to. At this point we do. So our definition of an index fossil means that this fossil has to be widespread. And that might not be the only way to explain it. It might be that there's long distances, great distances in between your fossils. You could say it's over, there's an ocean separating them. You could say that it has 15 kilometers or 10,000 kilometers between them. But either way, widespread means you've got distance between two areas that have rock layers. So that's what I mean and what we mean by widespread. Over a short period of time, normally when we discuss something that's a short period of time or lasting a short period of time, we're looking in the 1 to 10 million year range. Maybe we have an organism that was living in the ocean or on land, and that particular organism was very successful in the sense that it could live over the course, not one organism, but many organisms in that family living 1 to 10 million years. Okay. Occasionally we may end up with other events on this planet, such as asteroid impacts or volcanic eruptions, that also take place that are widespread and very short amount of time. Sometimes volcanoes can erupt within days, weeks, maybe even years, single years, and that is far smaller than our index fossils. So we can sometimes refer to those as index events. Okay? So this is something you want to ingrain in your mind, okay? And that's why I've already done some of the highlighting, but if you can, put something in your own words over in the annotations so you can help learn this a little bit better on your own. Okay? We always learn things better on our own when we're using our own words to learn them. All right, let's come down here. We've got a couple of practice questions that are sort of based on the reading up there and what you already may have seen on page 8 and 9, the reference table. So if you want, go ahead and pause the video, try to answer these questions, and then I'll come back and we'll follow up with these answers. Okay. So now that you've had maybe a moment to take a look at these 3 questions and try to answer them, let's take a look. So why would a volcanic eruption be a good index event? Well, I just discussed that, and if you need to, go ahead and rewind the video so you can listen to my explanation of why a volcanic event is a great index aspect for our geologic timescale. Big explosions, ash goes into the sky, travels across the atmosphere, deposits across the world, lands, gets buried, and you have something that's widespread. And if it's a volcanic eruption that didn't happen over millions of years, then you probably have something that's short-lived as well. Why would sharks and alligators be bad index fossils? Well, if you had found them based on the earliest sharks and maybe the earliest reptiles, you can see that reptiles and even some of our earliest sharks, which should be right here, earliest ammonoids of sharks, they happened way back in the fossil record. Now, if you think about it, 416 million years ago, that's not exactly short, because we still have sharks around, the family of sharks, and we still have alligators and crocodiles around. So they are very poor index fossils because you can find them in each of these periods of time in rock layers out in the world. So they're no bueno, okay? Down here, why would humans be a good index fossil? Well, we're not, because we're still here, okay? So we may last as long as sharks, and we'll have to wait and see. So that's kind of a trick question. Let's move on. All right, so here I want to walk you through how to correlate 2 different locations so that you have a better grasp and maybe understanding of how to approach a question like this in your independent practice or even on the Regents exam. Okay? And just in general, this is just some really good problem-solving methods that will help you later in life anyhow. We do have questions over here, but I would like to wait for me to be able to walk you through these particular diagrams. So let's zoom in, and hopefully Carl, my smartboard's name, will behave with us today. All right, so we've got 2 locations. I'm going to do a quick check just to make sure that these are in the screen for all of you. Good. All right. We've got location A, location B. All right, we've got 5 layers here. We've got 5 layers here, 6 layers there across these locations. I would like to just say that right now, just for example's sake, they are separated by an ocean in between them. So there is a widespread distance between them. We go and take a look at each location, we can see what type of features might be available within them. So I'm going to see that in location A, I've been given a fossil. Not just any fossil, it's an index fossil. So it's very special, meaning for our purposes, it only occurs in this age layer, which is Devonian. If I go to location B and I see, do I have that same index fossil somewhere within these layers? I do. It's here at layer 4. Also Devonian. So if we find this fossil in these 2 layers, even though the layers are not directly across from each other, we can deduce and correlate that they are the same age. Okay. From there, we now have to build out the rest of these blank layers with period names and try to identify how old they are. So with Devonian, we're going to need page 8 because we need to try to figure out what's older than Devonian and what's younger than Devonian to finish this out. Okay. So if we go to page 8, we find Devonian here. Look underneath. We're going to treat this period just like it's another layer. So Silurian. That's what we have to start with thinking. So let's look, is there anything below layer 5 here in location A? No. I don't see anything down here that's telling us that 5 can't be Silurian. So by process of elimination, we can be safe to say that this is Silurian in age. Okay? If we go up, we'll do the same method. We'll come back here, find Devonian. Okay? In order for us to maybe break this down a little bit, this Mississippi, Pennsylvanian, those periods of time tend to be more focused on geology within the United States because they are directly related to states and layers of rock within those states that were discovered. Now, if we were to look at this from more of a global aspect, the Carboniferous is something that's referred to globally because that's the time period where a lot of coal deposits formed. So for our purpose and the example on the next page, I'm going to label our next layer that's younger than Devonian. I'm going to label it Carboniferous. Now if we continue that trend, instead of just going back and forth, we can get another few onto our diagram without having to jump back and forth. So next layer, Permian. Last layer, Triassic. So we have completed what we believe is the order of layers by geologic time periods. Over here, we have to try to figure out the same thing. So this is a different location. There may have been different environments creating different rocks at different times. So they may not be exactly the same down each column, but we do know that we can definitely start with this fossil Devonian. And so let's kick it off. We already know that underneath here is Silurian. So let's go ahead and label that up as Silurian. We run into a little bit of a hiccup, which is okay, because like I said, these layers may have been created due to different environmental conditions. So if I look at Silurian here, I've got this gap, and then I've got a fossil I have to analyze here. Turns out that this fossil is also Silurian. And we can't jump around with time periods. So whatever's in between here if we see that it's bookended by Silurian in layer 5 and Silurian in layer 7, then we have to say that, to deduce this, we have to say that layer 6 is definitely Silurian. You're going to see how that comes into play with some of your practice questions as well. Now, we don't have anything else to analyze beyond here in terms of fossils, so we go ahead and label layer 3 in location B as Carboniferous. And below layer 7, what comes before Silurian? You go back to page 8, you'll see that it's called Ordovician. So now you have completed accurately all the different time periods for all the layers in both locations by correlating two index fossils. Okay? Now, with the time that you have, I would say pause the video and attempt to complete the questions on the side here. So go ahead and do that now before we get into any guided practice or independent practice. If you'd like to jump just into guided practice, independent practice, you can forward ahead while I cover the answers to these questions, these 7 questions here. Okay, so now that you've had some time to take a look at this and answer these questions, let's start going through these questions so that you have some answers to follow up with. So, number 1, name 2 ways we know that layer 7 is older than layer 4. So 2 ways. First way, this index fossil is older. That's the first thing because we're talking about index fossils. Second comes from our first topic of geologic history, which is sequence of events, otherwise known as relative age dating. So if we take a look where 7 is and where 4 is, 7 is underneath, it's lower than layer 4. So due to the law of superposition, where it states that older rock layers are on the bottom and younger rock layers are on the top, 7 will be older due to the law of superposition because it's beneath. Number 2, what period could layer 8 be from? Well, we did that together, Ordovician. 3, what period could layer 3 be from? We did that together, Carboniferous. Number 4, what was the dominant life form on Earth during this period of time? So if you go to Carboniferous in the reference tables, if we look, we have abundant amphibians, so lots of amphibians. Abundant means a lot. Dominant means that they are all over the place and they're at the top of the food chain potentially. Okay? Now, number 5, which one could be from the Mesozoic? Well, we've got to look at our reference tables and find our Mesozoic era and then see which of these periods of time is in the Mesozoic. Triassic. 6, specifically name 1 other fossil that could be found in layer 7. Layer 7 is Silurian. So if we are looking at Silurian, we're going to need to follow across until we hit other animals that might have taken place in the Silurian or can be found in Silurian rock. So let's come over here. 1, 2, 3. This row right here, we've got letter E, H, M, P, U, Y. That's not the answer. And when you put them together, it doesn't spell anything. But these letters do correspond with these animals down here. So any of these animals, E, H, M, P, U, Y, will be an animal also found in the Silurian with that Eurypterid in the picture on layer 7. Number 7, would you find any human fossils in these layers? No, because these layers are far too in the past for us to have existed. All right, let's move on. So now, if you don't have it already open, go back into the Google folder, my Google shared folder, and open up the Fossil Correlation Guided and Independent Practice 1 document. And pause the video, try this out on your own first, and then we'll come back and we'll review it together. Okay, so now that you've had an opportunity to take on this question, let's analyze it together. I've got my reference tables, and if you haven't had an opportunity to, I'll bring it up a little close to you, so that if you haven't outlined your reference tables, you can outline it with some colors and make it a lot easier for you to follow across from the eras and get the information you need. All right. Now, let's take a look. The cross-section below represent 2 bedrock outcrops 15 kilometers apart. Numbers 1 through 9 indicate rock layers. Some layers contain index fossils. There has been no overturning. Remember, overturning, we've got our horizontal layers. None of this has happened. no folding, no returning, okay? So that definitely means what's on the bottom of each place is the oldest rock for that location. Okay? Now let's take a look. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And within those 9 layers, we've got 1, 2, 3, 4, 5 index fossils. We're going to use those index fossils to answer this question. Okay? Now, instead of saying widespread, they have given you that these are 15 kilometers apart, so they are not next to each other, and they're not visible next to each other. So, number 1, you've got to find that picture down here on the bottom of your reference tables. This one is Bothrioplepis, letter R. In order to figure out what letter R is, you find letter R on page 9, follow across until you hit the name of the period on page 8. So this one is Devonian. And it's a good idea to be labeling your diagram when you're solving these questions, because let's face it, there's too much information for us to remember every single thing that we do on this, and it's far easier to compare and contrast these particular locations if we have something written down. I don't know what layer 2 is yet, so let's just keep analyzing our fossils. So this one here, this is going to be Plerodictum. This is letter V. So let's take a look and see what period letter V is. Letter V is also Devonian. Well, we're in that situation like where we had a Silurian fossil and we had a Silurian layer and a Silurian fossil. The middle layer was Silurian. So we've got Devonian fossil, Devonian fossil. There's no other choice. We've got to make this one Devonian. Okay. Now let's continue on and see if layer 4 actually is older than layer 3. So we've got Cystophyllum, letter U at the bottom of the page. Find letter U, and sure enough, it actually is. This is Silurian. All right, so we have finished figuring out all the age of the layers for outcrop number 1. Let's figure out outcrop number 2. Outcrop number 2, we've got Mucrosporifer, which is letter Z. Letter Z is going to be Devonian. Okay. We don't have any fossils up here, so we can go ahead and assume that this is Carboniferous in layer 5. Okay. Layer 7, I don't know. Layer 8. Layer 8, what animal was that? That is Eosporifer, letter Y. So letter Y is Silurian. Oh, okay, so we're a little bit in a position where we have 2 different periods of time and no fossil in 7. So right now, we're going to say that this could be Devonian or Silurian. Could be one or the other, we don't know. Hopefully this won't come into play with our answer, but if it does, I'll help you with a solution. So layer 9 is older, and we don't have a fossil to tell us, so we're going to go ahead and label that up as the older layer or division. Now it's time to see which of these layers most likely formed during the same geologic time period together. So from each side, we have to pair up 1 and 8. So 1 is Devonian, 8 is Silurian. No good. Choice 2, layer 2 and 9. Nope, those don't match up either. Choice 3, layer 3 and layer 7. Maybe. Okay. Choice 4, layer 4 and layer 5. That's definitely a no-go. So in this case, we are to assume that layer 7 is Devonian because choice 3 is the best of all answers. The rest of them are completely bogus. So we get choice 3. So now it's your time to pause. Go ahead and rewind if you need to and check the video. Look at some of the examples. Begin your independent practice. Use my access points that are also located in the Google folder. And if you need to, check your answers. And as always, make sure that if you have any questions or concerns, feel free to add a comment below the video, and I'll do my best to get back to you. Thanks.